Okay, hi everyone. Today we're going to work on basic integrals and we're going to do power rules in reverse. So let's go ahead and review what power rule was to begin with. So let's do some quick review. If I ask you for the derivative of x cubed, right? We had a rule that we said if it's the derivative of x to the n power, the n goes to the front, right? Goes to the front, and we minus 1 from the exponent. Okay, so really two steps. First step was bring down n, and the second one was minus 1 from n, right? Our exponent. This is a little baby n. Okay. Those are our two main things for power rule. And how do we come up with that rule? Well, if you want to do limits the long way, sure. And we end up with that pattern. We could have done a proof for this and we would have seen no matter what n value we use, it's always going to bring it to the front and we're going to subtract 1 regardless of it. So as long as we have this polynomial idea here. So this is equal to, bring down the 3, x, and then 3 minus 1 is 2. Okay, pretty fairly easy, right? Now let me give you another example. What if I give you guys a square root? The square root of x, let's say x cubed, just talking about this, okay? So to rewrite this, what would my exponent be if I don't want to write it with that square root? The exponent is a 1/2 power, so if I rewrite it as 3 and 1/2 on the x outside, to write this, to skip a step, to make this easier, we would have probably rewritten it as x 3 over 2. I have 3 out of 2 x's. That's what radicals are. I have 3 out of 2. Okay? And then we would take the derivative here, and that would be 3 over 2 x, and then 3 over 2 minus 1. I'm going to say 2 over 2 because that's really the same thing as 1. And we're left with 1/2. Okay. What if I write it with a fraction? Okay. So one of the fast ways we said we would spin this around is we would go ahead and write this as a negative exponent. And then we could do our power rule on this. Oh, sorry, yeah. So it would be d over dx, negative 2, bring down, so sorry, I don't know why I wrote that again. Bring down the exponent, and then x to negative 2 minus 1, and negative 3. So the pattern does not change for these polynomials. Right. So easy peasy. So let's start off here as we talk about the steps that we use to go down, to take the derivative. We take the exponent and bring it to the front, and we subtract 1. Now, to go backwards, and that's what kind of an integral is, just the basic idea was we're undoing a derivative. Okay, the integral here. The process is really we're undoing. There is a bigger idea, and we'll get to that. Okay, we'll get to that, and we'll talk about what are the, I guess, the physics representation, how can we see this visually, and all this other stuff. But let's just do the basic math idea here. I'm trying to undo something, just like the opposite of multiply is divide, opposite of add is subtract. Let's go ahead and take the problem this. F of x, let's say this is going to be x squared, okay? And then I want to take the integral, and we write the integral with this long s symbol here, long s symbol here. If I take the integral of f of x, we have to say what variable is this in terms of. Just like when we took the derivative, when we wrote d over dx, we said we're going to take this in terms of x. So we have to say which variable we are working with. So that's dx here. So if I rewrite this problem, it'll be the integral of x squared dx. Right? Where f of x is my function, and we're writing in this framework. If we see this little integral sign, the integrand, and then we have our dx, which is our, I guess, variable that we're working with. Okay, and then so here's what we're going to have to say. What was this before I took the derivative? Okay, so if this is the result, if x squared is the result of my derivative, okay, if I say d over dx of something is equal to x squared, what was it beforehand? Now, we're going to work with this in going two things. Remember, to take a derivative, we did two things. We brought down the exponent, and we also minus 1. So for sure, to go backwards, we're going to add 1 to it. So for sure, we're going to say x to the 2 plus 1, right? Because we have to add 1 back to the exponent. We minus 1 to go forward, so we have to add 1 to go back. Okay. And then, didn't we take whatever number was in top and we moved it to the front? So what's the opposite of multiply? We have to divide, right? Opposite of multiply is divide. So we're going to now have to divide our previous number. So we did two things. We did two opposite operations. We added when we subtracted, and we divided when we multiplied. So that's the basic concept, is we're working backwards. Now, let's see if this worked out. We have 1 over 3 x cubed. Okay, I'm going to include one more thing here. I'm going to write a plus c here, and we'll talk about a little while later. Plus c, it is very important that we write a plus c. And we'll again mention that in just a little bit. But I want to make sure that this worked. Let's go ahead and take the derivative now of 1 over 3 x cubed plus c, where c is a constant. That is what we call a constant. Okay, so if we take the derivative of 1 over 3, 1 over 3, remember, is a constant, so we don't have to worry about the 1/3. That just work with the exponent. Okay, what happens to the 3? The 3 goes to the front. So it's, I'm going to just write it out so you guys can see. 1/3 times 3 x squared plus 0. Verify that for me. We move the 3 to the front, so it's 3 times 1/3. And we also subtracted 1 from the exponent. That's how we ended up with a 2 here. And as this simplifies out, this is really just x squared, which is back where we started. Okay. Seems a little confusing when I'm talking it out, because I'm trying to explain everything out at the same time. But when we are undoing a process, we have to undo everything. And a couple of things that we want to make sure is, first, since I subtracted 1 from the exponent, I'm going to add back 1. And since I multiplied, we're going to undo it by dividing. Okay. Okay, let's do another one.
What if instead of the x, they just give you a plain number, say like 5?
Then if it's, okay, let's just see this. The integral of the number 5 dx, okay? So let's look at this another way. What is the derivative of what would have given me the answer 5?
5x.
5x, great call. If I say 5x, the derivative of the x becomes 1, and we'll work backwards. So I'm going to write this in a way that would make a little more sense. This is the integral of 5x to the 0 power, because we can always write something with a 0 exponent to put it back. And if we use a power rule here, it'll be 0 plus 1 over 0 plus 1 in essence. So it would be 5x to the 1 over 1, which gives us
So an integral is what it previously was?
For us, yeah, like mechanically, that's how it is. We're going backwards to see what we came from. Okay. A derivative will take us forward, and an integral will take us back. Okay. We're going to talk about why do we write a plus c, is because, let me give you this example here. If I say take the derivative of 3x squared plus 6 and take the derivative of 3x squared plus 10. Would there be any difference in the answer? I'm getting 6x on one side and 6x on the other. Right? The derivative of the constant 6 and the constant 10 would go to 0. So whenever you take a derivative, you lose information. Now, let's talk about the derivative when it comes to a line. or what the concept of a derivative is. Remember the idea of a derivative gives you what? If I ask you to take the derivative of something, it's a way of finding change, to find the slope. So if I give you this equation here, and essentially I'm saying, hey, what is the slope of 3x squared plus 6? Well, the slope is 6x. What is the slope of 3x squared plus 10? The slope is 6x. The slope is the same. The only difference in these graphs is that one is a little bit higher than the other. All the slopes are going to be exactly the same for the given x. But if I ask you to go backwards and say, hey, what was the graph before? So if you walk into the room and I say, hey, here's the slope. The slope is 6x. Tell me what the original equation was. Well, let's follow our rules. This will be 6x, to put an invisible 1 in there, 1 plus 1 over 1 plus 1. And this will give me 6x squared over 2 is equal to 3x squared. Well, we got the 3x squared part, but do you see how we're still missing the constant value? That's why we have to write a plus c at the end. If you take the integral, you have to remember to write a plus c. And we'll talk about it when we don't write a plus c, but if it's what we call an indefinite integral, meaning there is no boundary here, it doesn't give us an a or b. A typical a definite integral, let me show you the difference in the picture of a definite and indefinite real quick. A definite integral looks like this, from 1 to 2 of x squared dx, okay? An indefinite is integral of x squared dx. The biggest difference here is one has values, and we'll talk about what these values mean later, and one doesn't. And when you don't have a definite integral, when you don't see that 1 to 2 or 3 to 5, whatever the a to b value, we call it a to b, we have to write a plus c. So this would be 1 over 3 x cubed plus c. Again, we'll talk more about that later. But you see all the answers that you guys will have to write today will have a plus c there.
Wait, can you explain that again? I'm confused.
If you looked at what we did right here, okay? When we took the integral, we got 3x squared, and that's what we're supposed to get. We're supposed to get 3x squared. But because I gave you the slope, it doesn't tell you anything about where the graph is supposed to be positioned. Think of a line graph. If I told you the graph of a line, let's say y is equal to 3x plus 2, okay? That's pretty easy, 1, 2, and then from here 1, 2, 3 over 1, okay? I gave you the slope and at least one point, in this case, the y-intercept. But what if I gave you a graph, and I say just graph m is equal to 3? Well, that's a slope. Where do you want me to start this graph? There's an infinitely set of possibilities. And that's the thing about us working with integrals. If I don't tell you any points, for instance, this is the idea of a value that we would start and finish at. But if I don't give you that, that's what we call an indefinite. It's indefinite. We're not sure where it's coming from. We have to include a plus c because when we go backwards, we don't know that number was 6 or 10. We don't know at all. Okay. So oftentimes when we're looking at these indefinite integrals, we have to write plus c because what if there was a constant? When we took the derivative, we had lost that constant. Another example is, imagine if your parents called you and said, how fast are you driving? It's a weird question. How fast are you driving? I'm driving 40 miles an hour. Do they have any clue where you're at? There's no position to that, right? So the idea is that though I might give you a speed, working backwards, I do not have a position. Right? Just because I know the slope, it doesn't mean I know where the graph is located. I just kind of know the trend of that graph. That's why we have to include a plus c. Let's go ahead and take a look at another example here. Let's take the integral of 1 over x squared dx. Okay. So to rewrite this, it would be the integral of x to the negative 2 power dx. You guys feel okay with this? Me changing it to a negative exponent? Now it's just a basic power rule. right? I'd rather work with power rule than some weird quotient rule. Okay, so we're going to go ahead and change this to x to the negative 2 plus 1 over negative 2 plus 1. And then we're at a plus c at the end because after you take the integral's gone. We've already done the undo process. You have to make sure you account for a constant just in case. Negative 2 plus 1 is negative 1. So x of negative 1 over negative 1 plus c. This is negative 1 over x plus c. Now, let's take the derivative just to double check if this makes any sense at all. The derivative of negative 1 over x plus c is, I'm going to rewrite this as the derivative of negative x to the exponent negative 1 plus c. All right, and we'll see if we end up with our starting value. The exponent goes to the front, that becomes a positive, and we minus 1 x to the negative 2 plus 0, and this becomes 1 over x squared. All right, back to where we started from. So one of the key things about doing these simple power rule integrations is that we're just working backwards, and you can always check them. Right? You can always check them. Now let me go ahead and give you the general form for this. So the integral of x to the n dx, okay? Where n could be any number. What do you think this is going to be? It's going to be x to the n what? What do we do to the exponent? We add 1, thank you. And then we divide by the n plus 1 version. And don't forget to write a plus c at the end because since this is an indefinite integral, there's no numbers in the front of that big integrand. We are going to have to include a constant just in case there was one. Eventually, soon we'll solve for what that constant could be if you give me any bits of information. It's like we're trying to dox the equation. Right? And this is our big formula. And you guys can see that in that little cheat sheet on the homework 1 page. Okay, so let's see. One more thing, just to talk about this. If you look at this, we are undoing two processes. We are adding one when we subtracted 1 to the exponent, and we're dividing when we had multiplied originally. Okay, so we undid the process. Okay, let's go ahead and do one more. We talked about the radicals, right? So let's take the integral of the square root of x to the dx, okay? All this stuff needs to be written. You need a dx because you need to tell me what variable I'm working with. All right, so let's rewrite this as the integral of x to the 1/2 power dx. Nice, 1/2. I'd rather work with 1/2 though it's a fraction than a radical. And we're going to do what we did before, x to the 1/2 plus 1 over 1/2 plus 1, right? That's literally what we're saying here. And don't forget plus c. If you do not write plus c, this will be marked wrong or you will lose a point. On the AP test, they would actually deduct a point. So maybe like 1 out of 6. So what's that, like 20% of your grade if you ever get the plus c? This is 2 over 2 as a fraction. So x to the 3 over 2 over 3 over 2 plus c. Rewriting this as, we don't like dividing fractions, we multiply by the reciprocal. X to the 3 over 2 plus c. All right, let's double check now. D over dx, let's go ahead and double check this. 2 over 3, x to the 3 over 2 plus c. I'm keeping that constant there. Okay. What happens to the exponent when I'm taking the derivative since it's power rule? 2 over 3, 3 over 2. They nicely cancel out, don't they? So let's go ahead and write it 2 over 3 and then 3 over 2. Those are going to go away. And x to the, let's do 3 over 2 minus 2 over 2 is 1 over 2. And then plus 0. So we're left with x to the 1/2 plus 0, which is the same as the square root of x. Back to where we started from. Okay. All right. So that's our lesson for today. That's pretty much it when it comes to power rule, okay? Okay, let's do one more question. 3x squared times x to the 1/2 minus 25 over x cubed. So this one looks a little crazy. It looks like a lot of stuff is going on. Now the thing is to simplify the problem first, if possible. So I'm going to actually simplify this by combining these two together. If you remember, if I'm multiplying powers, I'm actually adding them. Example, x squared times x cubed is adding x to the 5th. So I'm going to add those fractions together. So we end up with 3x to the 5 over 2. Why? Because 2 is the same as 4 over 2. And 4 plus 1 is 5. Minus 25 over x cubed. I'm going to still continue to rewrite this as if I divide by 3, I'm actually subtracting, right? So this is actually 3 x to the negative 1/2 minus 25 x to the negative 3. How did I do that? X to the 5 over 2 divided, so times x to the negative 3 is the same as me writing x to the 5 over 2 times x to the negative 6 over 2, and that becomes x to the negative 1/2. That's how I ended up with 1/2 there.
Well, you moved x to the third power on the top.
I divided them both.
Oh.
Yeah, I divided them both. So let me add a little step here. I said 3x to the 5 over 2 divided by x cubed minus 25 over x cubed. Okay, it was two different terms over a common fraction. So I had to separate it. And then when now we're here. Okay, now that we're here, then we can do them separately. So this would just be the integral of 3x to the negative 1/2, dx, minus the integral of 25x cubed dx. Okay. Now one thing I need to tell you guys this is, just like with derivatives, you can take a derivative of them separately. If there's a plus or minus, you can take the integral of them separately also. You can separate it. But when you do that, make sure you do include an integral and a dx for them both. You have to include all these parts. Okay. To go backwards, remember we're adding 1 to that. So it'll be 3x to the 1/2 over 1/2. How did I do it so quickly? Negative 1/2 plus 1 is just 1/2. So I did it to the top and the bottom. On the right, minus 25 x to the negative 2 over negative 2. Because negative 3 plus 1 is negative 2. And we do that on the top and the bottom. So answer in the end is going to be, let's see, fraction multiplied by the reciprocal will be 6.
We only put 1 C, right?
Oh yeah, thank you. And you're right, plus C. Yes, 1 plus C for both of them. You will hear, okay, we really are supposed to write 2, okay? We're really supposed to write 2. But what is, let me give you an example. If I write this, plus C minus blank plus C, okay? What is C plus C? You can call it C1 and C2, okay? Because they're both different. C plus, no, that's just another constant, C3. So here's the idea. If I took the integral, we write plus C. And I took the other integral, you're supposed to write another plus C. You're supposed to, okay? But what is a random constant? Not random, but what is a constant plus a constant? Just another constant number. We just don't know what it is. So what happens in the end, we just make sure you include a plus C at the very end of this problem, because it's a combination of all your possible constant values. It's a combination of all your possible constants.
Okay, so we don't need to show 2 of them. We're okay with just showing 1.
Yeah, after you finish the integral. Because we treat this like one problem, but it really is 2 smaller problems. Okay, and so the final answer would have been, if I simplify this, it would be 6 square root of x, right? Minus, so plus now 25 over 2 x squared on the bottom. I'll write x squared on the bottom because that was a negative, right? And then plus c. If I had to rewrite this. Okay, or you could have left this as 6x to the 1/2 power. Okay.